Respected dignitaries, dear colleagues and students, a very good morning to one and all. I'm glad to be a part of this conference. I, Dr. Sunita Gupta, from Agra College, Agra, would like to express my sincere thanks and gratitude to the organizers, particularly Professor Vats, for giving me this opportunity to share with you all my views on the topic Conceptual Challenges in Undergraduate Physics, Causes and Remedies. Friends, although COVID-19 pandemic has been a big disruption in our lives and is having many aftermaths, the positive aspect of the pandemic has been that it has given us the opportunity to rethink and redefine our priorities and restir ourselves in order to broaden our boundaries. During this pandemic, the technology has better connected us, and the digital world advancements have come out as a boon to us. In fact, ICT has given us the opportunity to share our views, problems, difficulties, and the possible solutions with others across the globe. I have divided my presentation into two parts. In the first part, I shall be discussing some of the causes of conceptual challenges in physics. And in the second part, I shall be discussing the remedies for some of the conceptual challenges that one has to face in understanding physics. This will be followed by the summary of the presentation and a list of references. Let me now highlight some of the causes. The present education system is more of rote learning and securing high marks. It confines the students to only the lower levels of thinking, that is, remembering and to some extent understanding. As a result, a large number of challenges are being faced by both the students and the teachers of 21st century. If one looks from students' perspective, many challenges are experienced by them. They may either be due to lack of conceptual knowledge, due to existing misconceptions, due to difficulty in understanding abstract concepts, or due to incomplete teaching tasks resulting from insufficient time allocated to the course. Today, in order to improve the quality of education, we as teachers need to divert the students from rote learning and encourage, inculcate, and nurture curiosity amongst them. We need to drive them towards higher levels of thinking so that they can learn to analyze, evaluate, and create like an out-of-box thinker. That is where the role of teachers of 21st century becomes very challenging. Friends, critical analysis is required instead of criticism. There is a need to research and create new methodologies in teaching and also to implement them as new teaching techniques. It would be more appropriate to say that teaching and research ought to have more symbiotic relationship, and that is where the diversified role of a teacher becomes significant. As a physicist, here I would like to talk about the conceptual challenges in the undergraduate physics. With physics housing a vast and diverse aspects of nature, right from the subatomic world to the world of celestial bodies, it is not possible to even touch upon all the challenges in this short time interval of about 25 minutes. So, here I plan to just give you a flavor of one or two. I will then generalize the second part of my talk. For the rest of the time, from now onwards, my focus will be on quantum mechanics. Being a part of physics community, we all know about the mysteries of nature. We know that electromagnetic radiation itself is very mysterious, as it behaves in some aspects as wave and in other aspects as particle, depending upon the experiment that one does. Moreover, at the atomic and subatomic levels too, matter also behaves mysteriously, as it too exhibits wave-like behavior. This aspect of matter does not manifest itself in everyday life. As a matter of fact, from childhood, we are accustomed to perceiving the surroundings through our basic five senses. The concept of object, particle, motion, space and time formed at this stage of mental growth endorses that this is the only possibility for perceiving nature. As such, both the above statements about electromagnetic radiation and matter are, in fact, very non-intuitive. However, they can be very well explained by quantum mechanics. After more than 9 decades of flourishing quantum mechanics, now we know that atoms, molecules, me and you, in fact everything exists only because of quantum mechanics. Now we all know that quantum mechanics is the driving force of physics, but it is abstract. If for a moment you go back into the history of development of quantum mechanics, you would be surprised to know that even Albert Einstein had a great difficulty with the idea of not knowing precisely the outcome of well-controlled experiment at subatomic levels, what today we know as Heisenberg's uncertainty principle. At that stage, his famous words were, "God does not throw dice." Even at that stage, he thought that it was ridiculous to have the outcome of a well-controlled experiment uncertain. But we all know by now that God does throw dice. In our curriculum, quantum mechanics is introduced to the students as a part of the modern physics course at undergraduate level. But even after studying quantum mechanics for 1 or more years, the students often possess umpteen misconceptions. Only a few of them have a good technical hand, but even they are unable to answer if the same problem is posed to them qualitatively. To be very honest, the qualitative understanding of quantum mechanics is much more challenging. I will cite before you some examples where the misconceptions existing in the students can be seen quite clearly. When the students are asked to write the most fundamental equation in quantum mechanics, a major percentage of students write H psi is equal to E psi, which is the time-independent Schrödinger equation, while actually the most fundamental equation in quantum mechanics is the time-dependent Schrödinger equation, for which Erwin Schrödinger received the Nobel Prize. There are many such misconceptions regarding wave functions, expectation values, Hermitian operators, and their properties. The list is quite long. Before I start the second part of my talk, I would like to restate here a famous quote by Benjamin Franklin. Tell me and I will forget. Teach me and I will remember. Involve me and I will learn. Let me repeat this again. Tell me and I will forget. Teach me and I will remember. Involve me and I will learn. You might think as to who this me is. Friends, this is being quoted on behalf of a student. Also, I'm sharing with you the average retention rates for various ways of teaching and learning. As you can see from the figure, the average retention rate for the methods of teaching falling under the category of instructional paradigm is quite low. For lecturing method, the average retention rate is just 5%, which increases to 20% if audio-visual aids are used, and to 30% if demonstrations are used together with lecturing. So as you can very well analyze, such ways falling in the category of passive learning or instructional paradigm are not the effective ways of teaching. On the contrary, if you see the categories falling under interactive paradigm or what we call as participatory teaching, the average retention rates are quite high. For group discussions with practicals, the average retention rate is 50 plus 75%, which is far greater than the sum of all modes of passive teaching. So, with this data in hand, the question is, can we suggest and implement some remedial methods so that our students are able to better understand the abstract concepts and learn to analyze and create in order to become out-of-box thinkers. This will also help them to enhance their overall personality. We as teachers need to develop in our students hunger and passion for the subject. And for this, we need to change our teaching methodologies. It is worth mentioning here that abstract concepts are unknowns for which we do not have appropriate examples. In order to make such concepts interesting and understandable, we need to relate them to everyday experience through analogies. These analogies should be practical, possible, and logical. Through them, we can compare a known with an unknown aspect, thus taking the student from the world of known to the world of unknown. In the process, helping the student in deeper understanding, learning, and long-term retention. And this is where the role of ICT gains significance. The use of ICT-based learning tools like quilts and other computer-based simulations available as open educational resources can make the topics more interesting and understandable. These tools, together with short questionnaires, MCQs of various types, followed by problem-solving sessions, can be used in class once or twice a week as supplements to the traditional lectures. Now, I would like to tell you about what actually are quilts. These are quantum interactive learning tutorials supported by National Science Foundation. These learning tools have been developed on the basis of research on students' common difficulties in learning quantum mechanics. The process of developing these tools is iterative, that is, research followed by the development, testing, evaluation, and then the refinement of material. Following are the main features of quilts that make them suited for challenging task of teaching and learning quantum mechanics. They are based on systematic investigations of the difficulties students face in learning various concepts in quantum mechanics. Their development process is iterative. They utilize visualization tools which help the students build intuition about quantum processes. There is an active participation of students in quilts as they are asked to predict what should happen in particular situations and afterwards providing appropriate feedbacks. They attempt to tide over the gap between the quantitative formalism of quantum mechanics and the qualitative understanding necessary to explain and predict the actual phenomena. There are many such tools available for teaching different courses in physics. These are few websites for open educational resources: opensourcephysics.org, khanacademy.org, test-india.edu.in, phet.colorado.edu. Well, we can also develop such tools depending on the need of our students. Dear friends, many of us are teachers either by choice or by chance. Whatever may be the reason, our aim should not only be to disseminate information or to be more refined knowledge, but instead our aim should be to work for the betterment of the students and to help them enhance their overall personality. To summarize, it is the essential need of the hour to reform ways of teaching and learning so that the conveyed concepts are better understood. We need to encourage and nurture curiosity among students in order to build a strong foundation for higher levels of thinking. For this, we need to have creative minds to switch over to activity-based learning. This will pave our way to shift from instructional paradigm to learning paradigm. Also, it is now almost a prerequisite to keep pace with the advances in ICT so that the IT tools can be used to bridge the gap between the haves and have-nots in physics education. At this point of 21st century, embracing technology for blended learning, that is, chalkboard plus ICT-enabled learning is obligatory. We as teachers have the responsibility of being on one's toes for the change, and I'm sure my colleagues will agree to this. This is the list of references. I would personally like to thank Professor C. Singh for permitting me to share with you all about quills. Thank you for your kind attention.